Hi, in this video we will discuss the principle of flotation. We will understand the principle of flotation. So this principle, basically, how does it state? It states that the floating object or the floating body, it displaces its own mass or weight in which it floats. So any floating object, it displaces its own mass or weight in which it floats. Let us consider the following scenario. For instance, you are having this beaker which is full of water. Then you take the piece of stone. For instance, this is the piece of a stone. This is a stone, and this is water. So basically, the weight of this stone, it will displace the volume of this water, and as a result, the level of water will raise up. So the mass of this stone will be the same as the mass of this water displaced. And also the weight of this stone, when it is placed in this beaker which is full of water, will be the same as the weight of the water which will be displaced. Now let us try to understand this principle by taking the same instance. For instance, this is the beaker which is containing some amount of water. Basically, the pressure of these liquids, it depends on height. You know, at any point here there is pressure. If you take this point here, there is pressure. This point here, there is pressure. This point here, there is pressure. So we can take the pressure at any point by dividing the force divided by area. We get the amount of pressure at any point. If at this point, in this point, in this point, in this point, you can use this formula. But also, we understand that force is given by mass times gravitational force. So we can say that the pressure is mass times gravitational force divided by the area of which that object will be acting. Now, the mass also can be obtained by taking the density of that water divided by the volume of that object. So we can substitute here that pressure now is equal to density times volume times the gravitational force divided by the cross-section area. Also, we understand that the volume is equal to the cross-section area times the height. So we can also write that the pressure now is equal to density times area times the height. Instead of writing volume, we can take area times the height times the gravitational force divided by area. So as a result, area and area, they cancel out. Now pressure is equal to this density times gravitational force times height. So because density and the gravitational force, they are constant, all of these two are constant, so we can write that the pressure, it depends on height, because density and the gravitational force, they are constant. So as you increase the pressure, you increase the height. As you increase the height, you increase pressure. That's what happened. But also, let us now take another instance, the same beaker, which is also full of water. You are placing the cylinder now inside this beaker. This is, for instance, the cylinder. This is the cylinder, which is placed inside this beaker. This is the cylinder, and this is the level of water. This is the water which is found inside here. So we can say that at the bottom here there is pressure. Let's say we are having, this is pressure 1, and at the top here we are having another pressure which is pressure 2. is pressure 2. And this pressure 1, it may be at the certain height from the level of water. This is, let's say, it will be at the height H1. And this point P2, it is at the height H2 from the surface level of the liquid. So now we can calculate the pressure at this point P1 by taking the delta times the gravitational force times the height 1. The pressure at this point P2 can be obtained by the same way, taking delta times the gravitational force times the height, which is H2. Now, which one will be having the largest pressure between this point P1 and P2? Basically, P1 will be having larger pressure because it is having large height, because the pressure depends on height. So if we find out the difference between the pressure, the change in the pressure now can be obtained by taking pressure 1 minus pressure 2, because this pressure 1 is now large as compared to pressure 2. So the change in the pressure, this will be equal to rho times G times H1 minus, because you are finding the difference between the two, density times G times H2. So now we can say that density, this is rho times the gravitational force, this is gravitational force times H1. So we can substitute, we can find the common factor, times bracket, this is bracket H1 minus H2. But what is H1 minus H2? Can you write that H1 minus H2, it is the difference in height between this point and the other point. So now we can write this is density times G times change in height. Okay? All right. So we can also say that because we understand that change in pressure is given by change in force divided by area. Now the change in force, this will be equal to change in pressure times the cross-section area. Right? Now the change in force here, this will be equal to change in pressure, which is rho. This is rho times G times the change in height times the cross-section area. Now what is area times the change in height? Area times the change in height, this is volume. Alright? So this is equal to rho times G times the volume of the water dispersed, because area times height is volume. But also density times volume, this will be equal to the mass of the water dispersed by this cylinder. Density times volume is the mass of the water dispersed. So the output now is equal to, it is mass of the water dispersed times the gravitational force. So there will be the existence of the output force between this point and this point, because of which the cylinder now will move up because of the output force. Now this output force, this is basically the output force. Output force can be obtained by taking the mass of that object, which is now the cylinder. Let's say this is the mass of the object times the gravitational force. This will be equal to the mass of the water dispersed times the gravitational force. Alright? Now we can arrive to the following conclusion. Number one, conclusion from this. Number one, we say that when an object is placed in water, the weight, this is mass of object times gravitational force, is the weight. Mass, it is the weight of the object will be equal to the weight of the dispersed water. So we can write weight of object is equal to weight of water dispersed. This is the first conclusion. But also, second, if we cancel out this gravitational force and the other gravitational force, we can write that the mass of object This will be equal to the mass of water dispersed. So this is the two conditions to remember. Right? Okay. Thank you for watching. Don't forget